In this video, I want to go over how to solve quadratics, finding their zeros or x-intercepts by the completing the square method. So, in previous lessons, we've gone over how to solve certain quadratics that have only rational or rational answers, right? So we've been able to solve things like x squared plus 5x plus 6 by simply factoring x plus what multiplies out to 6 and adds up to 5. Well, that's 2 and 3. And then setting each one of those equal to 0. And solving. So x is equal to -3 and -2. That's where that function hits the x-axis. Now, some problems you cannot solve using this method. If the zeros happen to be irrational, okay, like the square root of 2 or something like that, or they happen to be imaginary, like 3 plus 2i, then you cannot use this method or AC method factoring to solve. So we have to use another method, and that method is called completing the square. Completing the square uses perfect square trinomials. If you remember what a perfect square trinomial is, it's something like this: x squared plus 14x plus 49. Okay, this can be factored into x plus 7 squared. Or something like x squared plus, another one would be 6x plus 9. Okay, this could be factored into x plus 3 squared. If you don't remember about perfect square trinomials, please watch the perfect square trinomial video. But we're going to use this idea, okay, to solve quadratics that were previously unsolvable. Okay, so let's take an example. Let's take the example of, we'll set it equal to 0. 0 is equal to x squared plus 6x plus 1. Okay? You cannot solve this using the AC method or guessing and checking. You have to use an idea called completing the square. Okay? And this is how we do it. I see that I want to somehow make this equation into a completing the square equation. And I'm going to do that by replacing this 1 with the number that is going to make this quadratic a perfect square. So, the first thing I want to do is move the 1 to the other side. So I'm going to subtract 1 from both sides, and I get x squared plus 6x on the right. Okay? Then I want to add a number to the end here, and that number needs to be the number that is going to make this right side a perfect square trinomial. And we're going to get that number by taking our, if you notice, to go from 14 to 49 or from 6 to 9, what you need to do is take this b value, halve it, right? Half of 14 is 7, and then square it. If you take 6, if you have 6, it's 3. If you square 3, it is 9. So that's the relationship. And we're going to use that relationship. So I'm going to take my b value of 6. I'm going to halve it and square it. If I do that, half of 6 is 3. 3 squared is 9. So I'm going to add 9 to both sides. All right? So now on the left, we're going to get 8. And on the right, we can actually factor this into x plus 3 squared. An important thing to note is that this 3 is just half of our b value. All right, we're almost done. Okay, I have a square. I want to isolate x. That's my ultimate goal. So I'm going to take the square root of both sides. Okay, so I'm going to get plus or minus the square root of 8 is equal to x plus 3. Okay, I'm almost done. All I have to do is subtract 3 from both sides, and I get my two answers. My two answers are negative 3 plus, I can reduce the square root of 8 to what? 2 root 2. And the other answer is, so I have my addition answer. My other answer is my subtraction answer, which is negative 3 minus 2 root 2. These are my two x values where my parabola hits the x-axis. Okay? And if you notice, they are irrational, right? They have the square root of 2 on them, so they are irrational numbers. Let's go through another example. If I have 0 is equal to 2x squared plus, let's do 4x plus 1. All right. Actually, that's fine. 4x plus 1. Let's talk about this example. Now, it has a 2 in the front here. Actually, I have a 2 in the front here. So what I have to do is, a perfect square doesn't have any number in the front. Or it can, but in this scenario, we don't want it. So the first thing you do if you see a leading coefficient other than 1 is you have to divide it out on everything. All right? And here we get 0 is equal to x squared plus 2x plus 1/2. Now we can move on to our completing the square step. I'm going to subtract 1/2 from both sides. And I want to get the number, so I want to get our number that's going to make this a perfect square. How am I going to do that? Well, I'm going to take my b value of 2, halve it, and square it. 2 over 2 is 1, 1 squared is 1. So I'm going to add 1 to both sides. Okay? Now, I can factor this. This is factored into x plus 1 squared. On the left, we have 1 minus 1/2 is 1/2. All right? Now we take the square root of both sides. So we're going to get the square root of 1/2 plus or minus is equal to x plus 1. Okay? Final step, I'm going to subtract 1 from both sides, and I get my answers as negative 1 plus or minus the square root of 1/2 is equal to x. Now we could rationalize this, but I'm not going to bother for now. Normally we would rationalize this, but I want to just show you another example instead in our time here. All right. So say we have 0 is equal to x squared plus 5x minus 3. Okay? Again, can't factor it. Using AC method or guessing and checking. Okay? The only difference here is this number, this 5x, is not going to nicely halve. So I want to show you how to do that. Okay, there's no leading coefficient other than 1, so I'm safe there. I don't have to divide anything out. So I'm just going to start by adding 3 to both sides. All right. What number do I have to add to both sides to get the right to be a perfect square trinomial? Well, I'm going to do the same thing. I'm going to take my b value, halve it, and square it. 5 squared is 25. 2 squared is 4. So we get 25 over 4. That's the number I'm going to add. Let's make this 3 into a halves. So that's into a quarters. So that's going to be what? 12 over 4. Okay. Now, it might be a little difficult to see, but this is going to factor into x plus 5 over 2 squared. Okay, so when you are trying to find this number, it's just going to be this number that you haven't squared yet. It's going to be the b value halved. On the right, we have, what, 37 over 4. Okay. So now, I'm just going to take the square root of both sides. Okay. I'll subtract the 5 over 2, plus or minus. Okay, I can split up this into the square root of 37. And what's the square root of 4? The square root of 4 is just 2. Okay. And now, I can make my answer look a little nicer by putting everything over 2. So I have negative 5 plus or minus the square root of 37 over 2. And those are my two x values. Negative 5 plus the square root of 37 over 2, and negative 5 minus the square root of 37 over 2. I hope this helps.